Thanks everyone for coming. My name is Marvin. I work at SoundCloud. I work at the Android application. I work on a couple of backend systems. And today I'm going to talk to you about modularizing Android applications, a process we've gone through, we're still going through. I want to share some of the pitfalls we've seen, some of the problems we've run into, and some of the ideas we came up with to solve these problems. Yeah, basically it's about splitting up your huge monolithic application code base into nicer parts, into smaller pieces that you can use to get a better architecture, to get a better app in the end. Important to keep in mind, if you do refactoring and modularize your app, your end user is of course not going to see anything of that. The app will probably still look the same afterwards. But still, for developer happiness, for developer productivity, and for compile times, this is definitely an exercise that might make sense for you. Also, important to keep in mind, if you modularize your app, any advice I might give, it really depends on the code base and on your app, because every app is kind of different. It's hard to give like the one advice that will work on every app, so it's definitely going to be different. And also, since we're touching the build system, I'm mostly going to talk about Gradle pretty much exclusively, because I'm guessing most of you are using Gradle in your day-to-day development. Of course, tools like Buck or Bazel have been in talk when people talk about modularizing their apps. But there's great talks by the engineers at Uber in the past couple of years. So if you really want to learn more about Buck, for example, you can watch their talks, and they're available online as well. So to start out, what would be motivations why you would want to modularize your application? And there can be a huge range of different motivations. One for us was that our code base just got bigger and bigger and bigger and harder to manage. There were dependencies across modules everywhere, across packages everywhere. Some things were really hard to change. And so we took this as a step to say, we want to modularize our app to make it easier to work with. So that could totally be one. We just want to refactor some things. We want to encapsulate them better. We want to give things better APIs. That is definitely one reason why you might want to modularize your app, so that things are easier to comprehend and easier to change in the future. Also, if you're struggling from long build times, modularizing your app can help you. I'm saying can, and I'm not giving you any guarantees. It can also totally go the other way. Depends on your app, to be fair. But especially incremental compiles, and I'll share some tips on how you can really leverage that to get better compile times while you're working on a feature that you want to develop, to make it faster to compile, to make it faster to iterate on it, and to see changes. Also, modularizing your app, if you have heard of instant apps, that's probably one of the reasons why many people started being interested in that. So things like instant apps will, of course, will require you to modularize your app in some extent. But in general, modularization can make it much easier for you to support different platforms. So not just ship a big Android app, but also shipping an Android Wear app or an Android TV app by sharing the same components. And that will also be easier if you modularize. Short disclaimer, as I said in the beginning, this really depends on your app. And yeah, old code bases or inconsistency will make this easier or harder for you. I'm just going to share some of the struggles we've seen and what we came up with. And this is definitely not a refactor where you just go in and say, oh, let's quickly fix that. We quickly modularize something. That's what we tried sometimes, and it's never really going to work out. This modularizing, pulling out things into modules is something you really have to look at with care, and you have to slowly consider what the problems might be, and then you slowly chip away and start modularizing. This really needs a lot of thought. So to start out, let's look at a standard application, a really basic one, the file hierarchy of how this might look. So we will just have a bunch of frameworks or built out Gradle files to set up the build system. We have an application class and all that. And we have a couple features in here that are already nicely packaged by feature. We have a login feature, and we might have a content feature. So the app is basically just a login screen, and you go to and see some content. It's just really easy for the sake of example. And you already see the content feature has an API client in there. Why? We don't really know. It's just been there for a while, never really wanted to move it. So this are things that just like start happening in your code bases, and modularizing is a way to prevent that from happening as well. If you look at this a bit differently, we can just draw it like this. This is a huge box. This is your application module with your 3 packages. We have a login, a content, and an API client. And in your build.gradle file, you will define this as an Android application. You will apply the Android application plugin. And then this is basically what I would call a single module application. This is really just all your code is in this application module, in this app module as it's called. That's the default what Android Studio is going to spit out if you say, I want to create a new project. If you look at Gradle documentation or Gradle in general, Gradle will call this a single project build. So Gradle talks more about projects and not modules. I'm going to refer to modules, but if you look at Gradle documentation, don't get confused if you see the word projects thrown around a bunch of times. But what this really is, especially if your app is a bit older, this is a monolith. This is a huge monolith where everything is interconnected. It's super hard to change, and it has the same problems that a backend monolith might have, where it's really hard to make changes and understand which classes you might have to use to, like, everything kind of is open and everything might make sense to use, but actually the intention when you first built these classes was that some of them should not have been used. And the typical pattern when people want to get away from a monolith is splitting them up into more smaller microservices that are nicer to manage, that have a clear API. And basically the goal of this exercise is doing something similar in the Android world as well. So this could be basically a monolith, like everything's just chaotically thrown together. If you want this one book, so this one class down there, you need to pull it out and everything just falls over if you refactor that class. If you want to use another class, you have to handle all the books that are on top of it, and so basically the dependencies of that class. And yeah, it gets really messy and hard to change after a while. So we want to get to a state where we have something like microservices in an Android app. Of course, it's not microservices in the true term. Basically, what I'm talking about is defining a bunch of Android libraries. So you're already using them in many different examples. But basically defining a lot of Android libraries that act as a microservice. So something that has a very clear API, something that has a very clear responsibility, where it's really clear, if I call this thing, this is supposed to happen, and this is what it's going to give me. And it's also, especially if you have bigger teams and might work across different teams, each microservice or each Android library should have a clear owner, so that if you have to make changes or if you need to know more details about this library, that you really know who you can talk to. And you can really give each library a README file and really define, this is what this library is doing for me. And the library just doesn't have to be some utilities or features. It can really be whole screens, activities, fragments, views, everything. So basically, we don't want this huge chaotic book stack. We want something like this, which is well organized, where you can see on the end of the binders what is in there. What is it going to give me if I use this? So let's move toward a modularized code base. And typically, how I would approach this, if you look at your app, is really, you're the developers of this app. You see it every single day. Take a look at it. You probably know it best. You know the screens that are kind of hidden away. You know the big, complicated screens that are interconnected with everything else that are really hard to change, really painful. And to start out, really look at your app. If it plays music, play some music while doing so. And find these screens that are kind of hidden away, that are a little bit less dependent on everything else. Those might be good targets to start out with to get some experience of how it feels. But then again, it's not just enough to look at I found this one screen that's like has only one entry point and does nothing else. That might be true, but you also have to consider your code base. Just because the screen in the end does pretty much everything on its own doesn't mean it has a lot of dependencies to all the rest of your code base. So take your code base into consideration, take a look at it, and also see how things are depending on each other. There's a lot of different tools to show the dependencies between different classes that you can also use as plugins in IntelliJ. Those will already help you identify some components that are kind of belong together, some blobs of code, also some things that are really horribly interconnected that probably are really hard to change. And always aim to kind of encapsulate things a little bit more and have less cross-dependency between things. And really, as we want to do microservices or Android, split everything up into different Android libraries, look for these libraries, just as you might look at a library like OKHTTP to make network requests. Maybe you have something similar, a networking stack in your app. Some API that you call every single time you make a network request. How encapsulated is this? Can you use this and consider it a library of your own? Because something really important, libraries don't really have to be external. It doesn't have to be an OKHTTP, retrofit, ArcsJava, or whatever. It's not just something you find on GitHub and pull in via JCenter. It is something that you can create on your own, and it can be much more than just some utilities. It can be full screens, full activities, full features can live in a module. These libraries, you will import them pretty much the same way as you do the public libraries that you might use. And really go take a look at your code and try to identify these common libraries. We've, for example, stumbled upon some really small ones like connection helpers that tell us if the device is connected to internet or if it has a Wi-Fi connection or not, and if these changes. This might be a small library that you might use in your code base, and then you can just at least abstract it away, give it a clear API, and put it somewhere else that is not in the main blob of your code. So let's start modularizing this example that we had in the beginning. If we come back to our application, this is what it looks like. And one thing before we start, if you look at one other file that if you have a single module application that you might not really look at that much, that's a settings.gradle file. And usually, when you create a new project, it just looks like this. It's a settings.gradle file, and it just says include app, basically telling Gradle there is this module called app, and you have to consider this when you're running a build. And of course, as we are going to create more modules, this file will grow. We'll add more includes in there and tell Gradle, oh, I created a new module, and it's right here. So if we look at our application and we say we have this really thin wrapper for making network requests, so the API client package, for example, and it's really nicely extracted already in your code base maybe, then it would be a prime example to move it out into a library, into a module. And that's what you can do. You can just create a new module, put the code in there, so like remove it from the application and put it into the API client module that you've just created. And then, of course, make it an Android library, apply the Android library plugin, and your application will have an implementation dependency on this library that you've just created. Also, while moving the code, this is a great chance to revisit the API of this library that you're creating and really think, does this API make sense? Is this something that is easy to use? Can it be simplified? And also really important to keep in mind, if you move API client down like this and the application now depends on it, the API client can no longer reference any classes that are in the application module. That's really important to keep in mind, and it's probably once you start moving some classes around and you try to compile it, the compiler is just going to tell you a whole bunch of classes that are suddenly not available anymore because they live in a different module that you are not referencing. And this is then where it gets a little bit more hairy. But if I say, so when I'm saying move out this, create this module and move the code there, what do we actually mean? Where should you put it? I mean, there's different options, but if you're starting out to modularize your application, I would say if you look at our file structure again, basically don't put it out in a different repository, but just pull it out into a separate folder, a separate directory. Just move it out like that. Keep it in the same repository. You don't necessarily have to create a new repository, version it, publish it somewhere in your local Maven repositories. Keep it in the same repository to start out with. That's going to make it much, much easier on you if you want to make changes to it. You can like jump to a class in different modules through IntelliJ if you need to. And it's much easier to just change something. Of course, if you create a new module, it needs its own build definition. How is this module built? So you need a build.gradle file with all the definitions in there and to define its dependencies. And when you do this and you create this new module in your settings.gradle file, if we come back to that, you basically now tell it, OK, I have this module called app up there, and I also have this module called API client. And then Gradle will figure out that both of these exist. If you want to structure this a little bit more nicely, You don't just have to put every single module in the root directory of your project. You can also create subdirectories. For example, have like a modules directory or utilities or features or screens or whatever. Like you can name it whatever you want. Just in the settings of Gradle file, you have to give it that directory path as well in this kind of notation. So keep it in a single repository. Kind of go for a mono repository kind of way. And then if you want to share this, if you say this is a library that's super interesting, could be interesting for someone else, and you want to publish that or make it open source, you already have the benefit. Everything is already defined. You already have defined the build logic for just that part of the code. You already have a clean API. So if you really want to publish it at some point, then you could create a separate repository, put it in there, and then publish it and make it public. Also, if you have if your company is working on multiple apps, you could then also think about moving it into a different repository so that you can share the code between the different apps. So coming back to this, we pulled out the API client and we made it an Android library, but maybe it doesn't really need to be an Android library. Maybe it's just Kotlin or Java code in there. So what you can do is you can just apply also the Java library plugin. Then suddenly you get the added benefit that you cannot by any chance call any Android classes. That will fail compiling. So if you really want to have some modules or some utilities that should stay far away from the Android framework maybe, you can really enforce this by just not making it an Android library, but make it a Java library, or Kotlin if you prefer. That way unit testing might be easier. You don't have to mock as many Android classes away. And yeah, you get the added benefit of that, and you really make it clear in the contract of the library that this is pure Java. This has not necessarily anything to do with Android itself. Additionally, if you want to pull out files into a new module, IntelliJ and Android Studio with Android Studio v3, I think, got this new refactor operation called modularize. Which sounds really convenient, and in some cases maybe it also is, but this really depends on your code base. It could be a really simple refactor through IntelliJ. It could also end up doing something like this, when it just tells you, oh, move this 2,500 classes. That's not really the goal of modularizing necessarily. I mean, if it makes sense and these 2,500 classes really belong together, then go ahead, but most likely they're not. So this just shows it is very important to just take a good look at it, try to identify what is actually the API I want to achieve, what is this library that I'm building supposed to do. And it's probably not 2,500 classes big. And yeah, this shows, I mean, this is mostly going to be manual work, at least it has been for us. And this refactoring will also take time. It's not just a quick refactor and that's it. So if we continue, we've pulled out our API client. So next step, let's say we want to modularize a feature, have a login module that just shows the login activity. That's the only entry point. We can open the activity, and then the login screen opens up. And do it like that. So we would, let's just shift it over there, and let's pull out the login, create a login module and put the code in there. Then of course, our application needs to depend on the implementation of the login screen. And if you define an activity in your login module, in the manifest of that login module, the manifest merger in the end will take care of the activity also being in the final application. So you can define, you have a lot of different manifests scattered around different modules that then get merged together to one final application manifest. So the login screen probably also needs to make API requests, so we have a dependency on the API client. And then you start to compile it and think everything is fine, and then you realize, oh, after the login call was made to the API, we need to create a user object. But that's maybe still in the application, because the application also cares about a user object. So now your code doesn't compile. And then you start, well, I need a user module as well. So you put some user classes in there and make them depend on both. Fair enough. Then you try to compile it again, and then you realize, oh, there's some utils around text that I'm using in every of these modules. So okay, fair enough. We create a utilities module, and we make it depend on everything else. Okay, it looks a little bit more complex now. And then try to compile it again. The same thing happens. You realize there's more and more and more classes that you kind of depend on that you didn't consider in the first place. And you kind of end up going down a rabbit hole and just everything starts depending on each other. And then you run to the risk of really creating circular dependencies that are not really easy to spot sometimes. I would caution you to not just go for it and jump down and like, oh, pull out this module. Oh, this makes sense as a module as well. And then suddenly you end up creating 10, 12, 20 different modules just because you wanted to pull out that one screen into a module. And then you are really not in a better state than you started out with, because then you suddenly have 20 different modules where you don't know what they do, and then you just created them because you kind of had to make it work. And that's a really weird state to be in. In the end, if you refactor something, you want to end up in a better state than you started out with. And if you, I don't know, create 10, 20 different modules just for the sake of it, because you wanted to pull out one thing, it's not really a better state probably than what you started out with. So I would say be cautious. For some smaller modules, like an API client, for example, this might work perfectly fine. For bigger stuff, you really have to start considering upfront what this would entail, what kind of dependencies you might have to extract first to make this work in an easy way. If we go back to the beginning, I'm going to share a different approach to this and not just like pulling out things because they look like they make sense, but going for a little bit of a different approach. And this is basically, you have your application again, and basically you make your application a library. You just change the plugin. Instead of an application, it's now a library. All your code is in there still, all your manifests, everything. And you just create a really tiny wrapper that is then the actual application. Maybe your application class lives in there, but at the beginning it will be really small and contain almost no code. And all the code will be in your new base module. And then if you have something like the login, the code for the login screen, which, as we said, might rely on some user classes that are still in the now base module, then you can simply move it up. Define dependencies, but then you can still reference that user class. And you don't necessarily have to immediately start refactoring and creating all these different modules. You can just start out with this. And if you have your API client then, which might be a little bit more independent, then you can pull it basically down and not make it depend on the base module. And that way you can slowly but surely start chipping away at this base module monolith and really just slowly start extracting things that really make sense, and you don't have to suddenly create these 10, 20 different modules just to make it work, just to make it compile again. This transition from having just an application module to splitting it up into an application and a base module, this already will take you some time depending on your build setup, because this might change a bit. Some Gradle plugins really like being in the application module. But this will make it much, much easier to really just slowly chip away at it and not being in a state where you suddenly have to create 20 different modules. So I can recommend you try that. It might lead to a little bit of an easier transition towards modules. So let's talk about some different and sample apps. Because as I said in the beginning, modularizing your application might make it easier to ship some different apps. To create also sample apps, and I'm going to go more into detail about that. So if we say this is now our fully modularized application, we have a small base module, and we have the two features modularized in their own module. What we can now do, we have this application which pulls in both modules, but we could also do an Android Wear module, an instant app, and some sample applications, which then just pick and choose the modules that they need. The whole application probably will pull in every single feature module that you have. You want to combine all the features in one big app. The Android Wear app might not need all features. Maybe it has some other features, but you can share the code quite easily and have an Android Wear app. Also, the instant app is probably just going to be one feature of your application, so it's just going to pull in that one. And basically, sample applications and how we use them is, maybe you want to make some changes on the content screen. And so you create a small, whoops. So there we go. So you're going to create a really, really small application with a bunch of extra code to just pull in the content module. And every time you just launch the sample application for the content screen, you just launch immediately into the right activity. You might provide some fake data to make it look nice. And so then you can iterate really fast just over changes that you might want to make in the content screen. If you compile it, you don't have to compile every single feature again. You just have to recompile whatever is in the content module. And that might make it a lot easier and a lot faster for you to iterate over changes that you want to make there. So in the end, really, if you want to modularize your application, really think about the APIs that you want to achieve. Think about them really as libraries, as something you might want to publish at some point. Give these things a README, for example, and really say, oh, this is the login screen. It provides UI to log in, it makes network requests, and when the user clicks next, we should launch some other screen. Also, make it clear who owns what. If you have different teams, really make it clear, for example, also in the README that, I don't know, some API client module is more of a core responsibility, so your core team might own that. So if you want to make changes there, they can do it under the hood. It's important to keep in mind the more modules you'll have, the more maintenance you will have. You will have to spend more time maintaining those and maintaining the different modules, the build setups. That is, of course, going to go up. Overall, I would say compile times will go down. Not necessarily a clean compile time. That will not change much because you will still have the same amount of code in the end if you modularize. But an incremental compile should theoretically be much faster. So you might ask why? Why does it compile much faster? So one reason might be that you can tell Gradle to compile things in parallel. So if you have 5 different feature modules that you can compile in parallel, that might be faster than compiling one huge blob. Also, if you make changes in one single module, if you have many modules, you might not need to recompile everything, every single part of the application again. So basically, if you have this monolithic app and you make a change somewhere in there, in the worst case scenario, you're going to recompile everything. Also, annotation processors currently don't support incremental compiles yet. With a new Gradle release from yesterday, version 4.7, they added support for it. But also annotation processors have to implement this feature for it to really work. So in the worst case, you might have to recompile the entire app. If you have a more modularized application and you make a small change in this module, for example, in the worst case, you'll just have to recompile these 3 modules. And that is, of course, much less of the code that you finally have to recompile, and this would bring you a much faster compile time, or at least it should. That's also what the founder and CEO of Gradle keeps saying in his talks, is that Gradle actually doesn't really like big modules, much prefers having smaller modules because then Gradle can figure out what it actually needs to recompile. But just Android apps seem to be this huge monolithic code bases most of the time. So a couple more hints and pointers and like things that will make it much easier to modularize your applications. When it comes about declaring dependencies, dependency declarations have changed a bit with Android Gradle plugin v3.0, and I hope you're already all using this. But the old compile keyword that has been deprecated and replaced by API and implementation, and you probably all use this already, or at least I hope so. Quick recap: API. Defining something as an API dependency basically means this should be part of the public API of this module. And so the dependency will bubble up to any user of that module. An implementation dependency is more of an implementation detail, and it will not be available to upstream modules. And that way you can also kind of hide away some dependencies. So your API client, for example, can hide away that it's using OKHTTP under the hood, because your application in itself doesn't really, your features don't need to care if you use OKHTTP or retrofit. You have your own interface in the API client module. And that way you can hide it away. So to further showcase this, if we have our API client and we use OKHTTP, if we define it as API on the left and as implementation on the right, if we use this API client in our application and we want to import the OKHTTP client, if we define it as an API dependency, we can use it. We can use OKHTTP client, no problem. On the right side, if we use it in implementation dependency, we cannot use OKHTTP directly, and that way you can really nicely abstract away some dependencies that you might not need to share with all over the code base. So for example, it's in that way, it's impossible for someone in the application to say, oh, I need to make a network request. I'm just going to create an OKHTTP client real quick. I'm going to refactor that later, which obviously never will happen. But so it's much better to just hide away some dependencies. Also, it's really important, the more modules you'll have, the more places you will have where you define which dependencies you use. So really define the dependencies that you use in one single place. We have a dependencies.gradle file. I know that others call it a libraries or a versions.gradle file. It's basically a Gradle file with a bunch of variables that you declare, and where you say, these are the dependencies I use, and these are the versions that I use of these dependencies. This really is to assure that you're using the same dependencies across all different modules. So you're not using a really old version of RxJava in one module and the most up-to-date version of RxJava in another module, and then you rely on Gradle to just use the newest one everywhere. But if you just use the same version from the get-go, this really makes it easier on you to not run into runtime issues or compile time issues that are hard to debug. Also, if you have core dependencies, so if you, for example, use RxJava everywhere, then maybe it's something that you don't want to redefine in every single module, so you might make it part of some base module where you share that as an API dependency. So this could look something like that, where you define RxJava dependency in your dependencies.gradle file, and then in your build.gradle files, you just say, I depend on the library RxJava2. And you use that everywhere in all the different modules. And that way, if you want to bump the version of RxJava to a newer one, you simply have to do it in the dependencies.gradle file, and this will automatically be applied to every single module that you have. And this is really important to not it makes it much easier to not have to go to 10 different build.gradle files to just update a version. This is a more basic setup. There's also a blog post by Sam Edwards to use Kotlin and the magic build source module that Gradle offers. To also get auto-completion for the libraries that you're using and for the versions that you want to define. If you Google for that, you will find it shortly. And on a similar note, if you are defining an Android library, you probably, in every single Gradle, build.gradle file, you'll have to define this, like, oh, this is an Android library, and there's the Android block. This is my compile SDK version, this is my min SDK version. And you probably also want these target and compile and min SDK versions to be the same across all your modules. And not have, I don't know, one module, one Android library that targets SDK 23, one that targets 27, another one that's kind of stuck on 19 for some reason. You want to use the same version all over the code base, probably. So what you can also do is extract away this basic definition of what you treat as an Android library in your code base, and put it into a Gradle file itself, and then in your actual module, you'll pull in this basic definition. So apply this basic definition of what an Android library is for me, for our code base, and then only define the dependencies that are special to that module. So for example, in our code base, we use Kotlin, and the Kotlin standard library is probably core to every single module. So in our basic Android library definition, we are saying, the Kotlin standard library is just going to be applied to every single module that uses this file. But if, I don't know, this is a networking module, and it needs an OKHTTP dependency or a retrofit dependency, then you can really see in this dependencies block what is special about this module. What does it need to work? Similarly, you might want to think about centralizing some of the resources that you're using. For example, colors and dimensions. You probably don't want to define the color blue 20 times all over the code base. You probably want to use the same blue everywhere. So you can have a module for that, or have some sort of an UI components module where you define your basic definitions of what UI components mean to your application. And there's more. Dimensions could be one, so that your app looks uniform. Strings could also be an example, not necessarily maybe. Strings could be something that are very specific to every single screen and feature of your app, so they are special to the module that they live in. And layouts, for example, layout files, they are very specific to the feature they belong to, so they will probably be resources to that Android library. Let's talk about testing, because testing is important. And also, if you modularize your app, testing is equally important. So you should all be testing every single module that you have. And as you have a clear API for your module when you extract it, or hopefully you do, then this really gives you an opportunity to test this API, to really thoroughly test that the module and the contract is correct. So if you, for example, have an Android library, you can also do instrumentation tests. You can run espresso tests on that library. So for example, just have instrumentation tests for the login screen in the login module to verify that the screen is working correctly. But one thing to keep in mind, as you have more different modules that have to also work together, and to have some sort of a suite that does integration testing, that really verifies that if I click on the login button, it also goes to the correct screen, and it's not just every module tested for itself, but also all modules tested together. That's a really important point to keep in mind as well. And of course, unit tests, they just work in every single module. And if you have a pure Java or Kotlin module, you of course have even the benefit of having an easier time with testing, because you don't need to mock as many Android classes as you might have to mock otherwise. Because probably a lot of people are using dependency injection, I'm going to cover this as well quickly, but this is really dependent on how you use dependency injection frameworks and how your setup is. So basically, Dagger works across modules, and you can use it just fine, and you just have to define how your dependency graph is looking like. And what you can do, for example, is that in the Gradle module for the API client, you define a Dagger module for how these dependencies are provided. And then in your application module, you just import that Dagger module to kind of like get access to the classes inside the API client module. You might do it differently. For example, the injector notations on constructors also works across different modules, so that could also work for you. But again, this is really dependent on how your app is structured and how you're using, for example, Dagger or other dependency injection frameworks. What you'll definitely get towards when you do modularization is have more interfaces where you just define the definition of what a component is doing, and then then you can provide the actual implementation from other places through Daggers, through other dependency injection frameworks. But this is really something I would say is really dependent on the app and might work different across different apps. Also, something to keep in mind is navigation. When you have features and screens separated in different modules, how do you navigate between these modules? They know nothing about each other. So in our case here, if you click the login button, how do you go to the content screen? You don't necessarily have access to just say, oh, open the content activity, because the login screen doesn't even know that the content activity exists. So there might be some ways of saying, maybe you have intents with specific URIs that your application can parse and then say, oh, I know this is in the content module, so I have to launch this activity. You could have something like an interface that the login screen defines that it has a navigation target for the content, or like a post login screen that needs to be launched. And then the application can define the actual implementation on how to go there. So to wrap this up, one way to start and get experience with with modularizing your app might be new features, might be new utilities that you start writing. You can experiment putting them into different modules as well, and then you don't have to do the extraction work and realizing what kind of dependencies are there. Also, identify some core modules to your application, some things that really might make sense being kind of a base module or a core module, also for testing frameworks, for example. And it's really make a plan and extract slowly. Don't jump into the rabbit hole and just define 20 different modules because you kind of need to do it right now to make it compile again. That's not going to give you any benefit in the long run. Really try to make a plan and take an assessment at the start of what work needs to be done to really extract something into a module. And once you're there, enjoy the multi-module world. I hope you'll get some benefit out of this. And yeah, that's time for me to say thank you.